Hello and welcome everyone. Very happy that we are all together again. In this very fast tutorial, we will take a quick tour on the solar system energy as a whole to anchor some basics that we need to learn during this course. So fasten your pill and let's get started. Our aim of this lecture is to know what is the basic concept behind the solar energy and its use. Since we are at the very beginning, we need to start from scratch, and during this course we will go in depth step by step. And the second step is to know what is the different type of the solar energy technologies, what are the different topologies available to use in the solar system world. That's good. Now, very basically, the solar system energy is a system that takes the energy produced from the sunlight and convert it to an electrical energy that we can use and take the most benefit of it in our daily use. So the solar energy take an input and it produce an output. The input is the sun energy and the output is the electricity or the electrical energy. Alright, but we need now to know what exactly the sun energy consists of to take the most use of it. So the sun energy consists of two parts. The light produced from it to make our beautiful day too bright, and the second part of the sun energy is the heat produced from it. And this heat gives us the required energy that we use mostly in our life. And by a little thinking, you can estimate that each of those two types of energy is used in the solar electrical energy production in different way. So we have two main types of the solar energy production depends on the type of energy used. The first type, which depends on the light, is called the solar photovoltaic technology. Therefore, at this type we have some solar panels as you see here, and this solar panel absorbs the light that is radiated from the sun. Then, by some means of technology that we will illustrate later in details, the light is converted to an electrical energy. Now, the second type of the solar energy is the solar thermal technology, and at this topology there are some means of mirrors that attracts the sun energy on it and it concentrate it. Then the concentrated sun rays are reflected from the mirror and falls onto some tubes like this one here. And those tubes absorbs the heat from the sun rays. Then this heat is used to produce electricity by converting it from the thermal energy to the electrical energy by some means that we will illustrate also later. So at conclusion, these two different systems used to produce electrical energy from the solar energy, the photovoltaic and the thermal type. Now let's talk about the first type and the most important type, which is the photovoltaic system. Here, the photovoltaic solar system consists of two main types. The first one is the off-grid system and the second one is the on-grid system. So let's differentiate between them. Here the off-grid system, and from its name it's disconnected from the electrical power supply or the electrical utility. So it's not connected to the company that provides you with the electrical energy. Therefore, you can say that it's a local system because the power flow of the electrical power generated is going through some local devices to supply them, and it doesn't go through the utility. And the components of the off-grid solar systems are the solar panels that receives the sunlight, then it converts it to a direct electrical current, and this direct current or DC current is going through some charger controller. And the job of the charger controller is to control the flow of the DC electrical power from the solar panel, and the power gets out of the charger to enter the batteries, and we use the batteries to store the electrical energy so we can use it later or at any time we need. This is because the sunlight comes only during the day, but suppose that we need to use the electricity in the night, so we use some kinds of batteries to use it at any time we need, or to use the electricity stored at any time we need. But the problem now is that the stored electrical energy is a DC current, but the most electric devices or the most electrical appliances we use works on an AC power or an alternating current. So we need to convert this DC current to an AC power. And for this reason, we use an inverter, which is the powered electronic device that converts the DC power to an AC power. And finally, this electricity is ready to be used for our electrical photovoltaic solar system, and for this reason it's an off-grid, as you see, because it's not connected to the electric main power supply or the main utility. So the flow of electrical energy is a local one, only to supply your devices. And now the second type, which is the on-grid solar system, and you can guess from its name, it's the inverse of the off-grid solar system, as the output power of this system is going directly to the electric utility or the electrical grid. So its construction is more simpler than the off-grid system. Here the DC current comes out of the solar panel, is converted by the inverter from DC to an AC power, and then this AC power is injected directly through the grid. So this is the basic difference between the off-grid solar system and the on-grid solar system, and for this reason the on-grid solar system produces a global flow of electricity as it's injected directly into the global grid. And the final thing that we have now is the hybrid system, as the hybrid system is a combination of the on-grid and the off-grid solar systems, as the electrical energy goes through the utility, through the inverter, and the other part is continue pathing from the charger to the batteries, then the inverter. Finally, it feeds our electrical appliances and devices. So those are the different photovoltaic solar systems: the off-grid, the on-grid, and the hybrid system, which is a mix or a combination between the off-grid and the on-grid. And at this point, we are finished. And those are the links for the photos that we use in this lecture for preparation. Hope that's clear right now. Thank you for watching and see you next lectures.